So we did have a test last Wednesday, you might recall. I have them graded. There's still one person who needs to take it, and she's planning on taking it tomorrow after school, so you'll get your test back on Wednesday. So now we move on. Chapter 29 is about control systems. So I mentioned to you last week that starting this week and for next week, we're going to be delving deeper into some of the systems. Chapter 29 is about the control systems, and so that's what we're going to talk about today. I had hoped that we would get through 2 systems, but I think we'll only get through 1 today. That's okay. Tomorrow, the goal is the circulatory system, which is chapter 30. And then on Wednesday, we will be doing a lab, and it looks like the weather's going to cooperate with us because part of the lab we do outside, so that's nice. So on Friday, we'll talk about the immune system, and then all of next week is devoted to reproduction. So you can see on this list that we are skipping a little bit. We don't have 32 and 33 on this list. Okay. We already did chapter 33, the skeletal and muscular systems. This actually on page 1021, these questions, can you believe this? We're on page 1021. That is concerning chapter 33, skeletal and muscular. And chapter 22, we're just not going to do. So we're not going to talk about digestion and excretion. So let us begin our lovely outline. The control systems. The nervous system. We said the nervous system was one of the 2 control systems, and it's the fast-acting control system. We're going to take a little bit closer look at how it acts today. The structures of the nervous system. The nervous system is composed of the brain, the spinal cord, and the peripheral nerves. Now, on your test on past Wednesday, there was a question on there about comparing what's the difference between a vertebrae and a vertebrate. Now, some people said to me, so the vertebrae are the bones of the backbone. Some people said to me that they make up the spinal cord. That's not true. Okay? The vertebrae are the actual bones. The spinal cord, now we sometimes refer to this as the spine, but the spinal cord itself is this rod that Stanley is going up his tushy and is inside of the vertebrae, extending all the way up. That's the actual spinal cord. The cells of the nervous system. There are 2 types of cells, 2 categories of cells that make up the nervous system. The first are neurons. All right, so neurons, these individual cells, have 3 basic parts to them. Now, different neurons look different, but this is kind of our standard neuron, the most common type of neuron that's found in our nervous system. God bless you. This little circle in the middle here is the nucleus. So that little orange part is the nucleus. These little kind of hair-like projections are the dendrites. This long extension on the right-hand side is the axon. And this whole structure, this white structure with the nucleus inside of it, is the cell body.
Is the axon including the 3 prongs?
Yes, the 3 prongs are included in the axon. Neurons have 2 basic functions. The first is irritability. Irritability is the ability to conduct an electrical impulse. That electrical impulse is called, and you probably saw this term in your reading packet, is called an action potential. The electrical impulse is called an action potential. Now, electricity in any form, in the form of, for instance, the electricity that's going into the projector or going into my computer, any type of electricity is just the movement of charged particles. So we could take a closer look at this neuron. We're not going to get into the details of this, but we could take a closer look at this neuron, and what we would see is that charged particles are moving across the membrane. That's the action potential. I'm sorry, Mary?
Sorry, can you repeat that last part?
The movement of charged particles across the membrane is the action potential. That's the electricity. The action potential? Impulses start at the dendrites and move towards the cell body. Impulses start at the dendrites and move towards the cell body. From here, the impulse travels down the axon. So we have an impulse moving from left to right on our drawing. When the impulse reaches the end of the axon, we find its second function, the second function of neurons. The second function of neurons is conductivity. Conductivity is the neuron's ability to transmit the impulse to surrounding cells. The ability to transmit the impulse to surrounding cells. It does this using chemicals. Called neurotransmitters. These chemicals are released from the end of the axon. To communicate with the surrounding cells. So this is all about neurons, but I said that there are two types of cells that make up the nervous system. The other type of cells are the neuroglia. The neuroglia are the supporting cells of the nervous system. They support the neurons. Now, there are different types of neuroglia that perform their supporting role, if you will, in different ways. But there's one type of neuroglia that I want to mention to you. And this neuroglia acts as an insulator for neurons. So, for instance, I've got my power cord here, and presumably there's electricity flowing through here because it is plugged in and it's plugged into my computer and all that good stuff. Okay. Where is the electricity in here? Inside. What's inside of here? Wires, right? They're the ones that are conducting the electricity. So they're like the neurons. But I can hold this power cord without fear of electrocuting myself because we have insulation. And so some of these neuroglia perform that insulating job to keep the electricity inside of the neurons. organization of the nervous system, we're going to get away from our outline. We're going to stray from our outline and do our own little outline just about the organization of the nervous system. And the reason for this is, as you will see here momentarily, if we just started underneath organization, we'd be writing so far off to the right-hand side by the time we get to the bottom of this list. We'd be off the page. So, the nervous system as a whole can be divided into two parts. The central nervous system, the central nervous system is comprised of the brain and spinal cord. And the job of the central nervous system is integration. God bless you. So we'll talk a little bit more about what I mean by this integration. Obviously, if we're integrating something, we've got two things and they have to coordinate with one another. But we'll get back to that in a moment. The other major division of the central nervous system is the peripheral nervous system. That would be the peripheral nerves. Imagine that. So remember, the peripheral nerves are those that come off of the brain and spinal cord. The peripheral nervous system has two jobs. One is sensory input, so bringing in information about the environment. The other part is motor output, the other function. So responding to your environment. Motor output, which is responding to your environment. Sensory input is bringing in information about your environment. So if we go back to the central nervous system and we said that its job is integration, it's integrating this information from the peripheral nervous system. So integrating that sensory input to determine what the proper motor output is, what the proper response is to it. So we're integrating the sensory input, the information about our environment, to coordinate a response to that information. The peripheral nervous system, since it does have two different, very different functions, can further be divided into sensory, the sensory part of it, or afferent. So that's the one that's bringing in information about the environment. And motor output, or efferent division. The motor division of the peripheral nervous system can also be divided. into the somatic nervous system. You saw this on an assignment we had last week. This is the voluntary division. So this would be in charge of skeletal muscles, since skeletal muscles are voluntary. The other division then is the autonomic, which is the involuntary. So involuntary is going to deal with smooth muscle, cardiac muscle, and glands. So you've got all sorts of glands that produce hormones. You've got salivary glands that produce saliva. You've got lacrimal glands that produce tears. So you've got all these little mini body fluids flowing from the glands. Autonomic can further be broken down into sympathetic and parasympathetic. So we sometimes with parasympathetic, we refer to that as our rest and digest system. And sympathetic is our fight or flight response. So let's concentrate on sympathetic here for a minute. So let's not. Both of these systems, okay, are run by hormones. They are triggered by hormones. I should say their responses are triggered by hormones. Both of these systems are working in us at all times to help maintain homeostasis. But if something happens, a stressor, could be a physical stressor, it could be an emotional stressor, there's some kind of stressor that causes more of the sympathetic hormone to be made. And so you have responses, physical responses, that are preparing you to either fight your stressor or flee from it. So the stressor part? Okay, so if basically your body is gearing up to either fight the stressor or flee from the stressor. So things like increased heart rate, dilation of the pupils,
your digestion slows down. You don't need to be, you don't want to be using energy to digest food at that point. You want to divert that energy to the muscles where they can be used to fight or flee. Tear production decreases. Just kind of non-essential things decrease. Saliva production decreases, which is why you might, if you're nervous about something, you might have dry mouth. So once again, all these things are gearing you up to fight or flee. But then afterwards, so you think about this, you think, okay, well, when you're upset, you cry, right? People, I think of little kids, and when they're like throwing a big tantrum and they're crying and their face is all wrenched up and they're turning bright red, there's nothing coming out. They're going through all the motions of crying, but they're not actually producing tears because their sympathetic nervous system is kicked into high gear. But then after that's all over, what happens? Kind of crash, right? Because you stop producing so much of the sympathetic hormone and the parasympathetic is taking over now and going towards the rest and digest, trying to get you back to your homeostatic state. Usually goes a little bit too far the other direction before it manages to maintain homeostasis. All right. Now we may return to the outline. To our second control system. Which is the endocrine system. The endocrine system, we said, was our other control system. It is the slow-acting control system. And we will tackle that tomorrow.